Okay, so in this section, we're going to look at evaluating inverse trig functions. All right, so as a reminder, we've gone over, well, first of all, what is a inverse function, and brief kind of overview here. The arc cosine of x is equal to some value t, right? And again, think of the output as some function, excuse me, some angle t, right? And the input arc cosine is the ratio of the input x is the ratio of those sides of a triangle, right? So this is true if and only if cosine of t is equal to x and t falls between 0 and pi. Okay, and then the same thing for the sine, right? Arc sine of x is equal to t if and only if. This double-sided arrow means if and only if, that in English, right? So it means that this is a relationship that goes in both directions, right? Is equal to sine of t is equal to x again, and this will be true as long as t falls between negative pi over 2 and pi over 2 in case. Right, so the way you want to think of this is, okay, so if let's say we're given arc cosine of 1/2, all right, you want to say, all right, what angle gives me a value of 1/2? All right, and again, looking at this here, now remember, since it's a cosine, we're only restricted to values between 0 and pi, so 1/2, that means pi over 3, and that is the only solution. Right, when we were dealing with our trig functions, the circular functions, we saw that in some cases they're periodic, there were infinite values for a certain angle, but in this case for the arc cosine there is exactly one angle that gives 1/2, and that would be pi over 3. Okay, and again when we have, let's say, arc cosine of negative root 2 over 2, right, again for both of these, recall the range has to be between 0 and pi. Right, so we could say, all right, negative root 2 over 2, that shows up here and here. Right, so you'd say, all right, either one of those is correct. That is not true. Right, the range is here. Right, so this solution will not be correct. In fact, there's only one, and that being 3 pi over 4. Okay, and the same goes when working with the sine. If we have, let's say, arc sine of negative 1/2. All right, now in this case, remember the range is from negative pi over 2 to pi over 2. Okay. Excuse me. Okay, so here we have arc sine of negative 1/2. So that means between pi over 2 and negative pi over 2, that's in a quadrant 1 or quadrant 4 angle. So sine is negative in the quadrant 4. So negative 1/2 corresponds to, remember we're going in the negative direction, so that would be negative pi over 6. All right, and so for evaluating arc sine of root 3 over 2. All right, again, looking at that, positive, so we're restricted to the first quadrant. That would be a positive pi over 3. Okay, and again, those are the only solutions, right? Notice that when we were dealing with just trig functions, we said they were periodic, right? So they were in different quadrants, but here there is exactly one output here. All right, now let's take a look at compositions. Now, a property of inverse functions, right, in general just algebraic inverse functions, is if you take this composition, we get back the value of x, the identity essentially, and vice versa, right? If you just flip around the inverses, this would be true. Now this kind of relationship does hold for the trig, but there are some caveats based off of the fact that we've had to restrict the domain in order for an inverse to exist. Right, so what I mean by that is that we could in fact make the statement that the cosine, arc cosine of x is equal to x. Here, as long as the absolute value of x is less than 1, right? And that's just in general, right? With the value of the cosine can't be bigger than 1, the input. All right. The tricky part is when we flip around the arc cosine of x, the composition. This is equal to x as long as if x falls between 0 and pi. Okay. All right. And again, that has to do with the initial kind of restricting of the domain in order for us to create an inverse. All right. And then similar for sine, arc sine of x. This is equal to x. Again, provided that x is between -1 and 1, or these two inequalities mean the same thing. All right, so that's in general, right? If we try to input anything larger than 1, we'll get an error function because it's just out of the sine function cannot attain values that are bigger than 1 or less than -1. All right, the tricky part comes when we switch around. This is equal to x, again, provided that x falls between -pi/2 and pi/2. Okay, so let's take a look at some compositions. All right, so let's say that cosine, arc cosine of -3/5. All right, again, the value falls between -1 and 1. That is enough to simply jump right away to -3/5. Okay, that one's easy. All right. So now let's take a look at, well, what about arc cosine? And again, notice here that here the input here of the arc cosine is the ratio of the sides of our triangle of the acute reference angle. Right, the output, right, is going to be an angle. Right, so we'll notice that here when we rewrite this. Okay, so again, input of the cosine is an angle, and then the output of the cosine of that angle would be the ratio of the two sides. Okay, now here it would not be correct to say this is 7pi/6. Right? It's nice in algebra when we have inverses and we know they're inverses that the composition leads us to that, but these trig functions, they work a little bit different, right? And again, that's due to the fact that we restricted the domain to even define these functions. All right, so instead, the way we want to evaluate this is, right, we know 7pi/6, again, my trusty unit circle here. That's out here, right? So the value of the cosine is negative, right? Reference angle of pi/6. So the corresponding one between 0 and pi would be the angle 5pi/6. And now I'm within the range of the inverse. So this one is in fact equal to 5pi/6. Okay, and again, the reason for that is 7pi/6 is here. Cosine is negative there. Right, so our cosine is 7pi/6. Right, essentially what we're doing here is our cosine 7pi/6 is -√3/2. And again, looking for angles between 0 and pi. That gives us -√3/2. That is 5pi/6. Okay, so that is kind of the thought process right there. Okay. All right. So that's how you kind of want to approach these compositions of the same function, right? The same cosine and the arc cosine. Now, what about when we mix them up? All right. So let's say, for example, we have, what is the sine of the arc cosine of negative 3/5? Right? Okay, so here's what I want, how I want to think about this problem. All right, if we have the arc cosine, let's forget that extra c there, arc cosine of negative 3/5. Remember, the output of a inverse trig function is an angle. So let's call it t. All right. Now this statement is true if and only if, right, when we first started this section, we said the definition of an inverse is that this statement is true if and only if cosine of t is equal to negative 3/5, right? Where t for the cosine is an angle between 0 and pi. Well, now we can go to our right triangle trigonometry. Cosine is negative, so it's somewhere in the second quadrant, right? Remember, t is only restricted to quadrant 1 and quadrant 2. All right, so that's t. This is our t reference, so we can say from our right triangle, hypotenuse is 5, the x value is negative 3. Using a Pythagorean, we said this will be 4, right? A positive 4 because of the quadrant that it's in. So going back to evaluate this with some substitution, this is just an angle. We called it t. So we have sine of t. Right? Well, now let's look at our reference angle triangle. Sine of t would be 4/5. Right? And positive. All right, and that's how you work with the when we kind of mix up the sine and the cosine. Okay, let's take a look now at our tangent and arc cotangent. All right. So f of x is equal to the arc tangent of x. All right, and again, similar to our arc cosine and arc sine, arc tangent of x is equal to some function t. Again, if and only if, right, tangent of t is equal to x, and t is between pi/2 and negative pi/2. Now this is strictly between, right, since the tangent is not defined at pi/2 or negative pi/2. Okay, so that means that when we have compositions like the tangent, arctangent of x, this will be equal to x. Now this, there's no restriction on x. This will be for all real numbers x. All right, and the other way around, arctangent, tangent of x, this would be equal to x. Now here, as long as that x is between, strictly between negative pi/2 and pi/2. Okay. For the cotangent, the arc cotangent of x, right? So here, the arc cotangent of x is equal to t. Again, the output is some angle, right? If and only if 0 less than t less than pi, and again, strictly between 0 and pi, since the cotangent is undefined at 0 and undefined at pi. And the cotangent of t is equal to x. All right, and for the compositions, the cotangent arc cotangent of x is equal to x. This holds for all real number x. X, and then the arc cotangent of x. And again, this provided that x falls between 0 and pi. If it does not, then we'll find the corresponding angle that does, right? A reference angle that does fall within those parameters. Okay. All right, so let's look at some examples here. So the arc tangent of root 3 is equal to some value t, and again, this is true if and only if tangent of t is equal to root 3. All right. Okay, now remember that we are restricted for that angle t for values of pi over 2 and negative pi over 2. So angles in quadrant 1 or quadrant 4. All right. Remember, the tangent is the ratio of the sine over the cosine. These all have the same denominator, so really just look at the numerators, right? Root 3 over 1 sine over cosine would be this angle pi over 3, right? And again, this is the only possible value, right? It is not the angle that would be out here, right here. Right, where we take negative over negative is a positive. The domain restriction is crucial here for our inverse functions. Okay. Excuse me. All right, and the same here, arc. Let's do one more example. Arc cotangent of negative root 3. All right, is equal to t. And again, here what we're looking for are values, or the value of cotangent of t that equals to cotangent of t that equals to negative 3. Right, and again, we're looking for cotangent. The restriction is between 0 and pi, and that one is sine over cosine. So it would be in the second quadrant since it's negative. One of them has to be negative, and we're looking at 5 pi over 6, right? Negative root 3 over 1. So in this case here, this is 5 pi over 6. Okay. All right. Now, this does take some time, right? Practice time, kind of understanding, going over how to work with these inverse trig functions. The trig functions, just in general, they work a lot different than than all of the algebraic functions that we've seen in our math careers up to this point. So just remember that, right? These brand new rules here. All right, let's take a look at a composition. All right, so if we want to do, let's say, the cotangent arc cotangent of negative 1, right? And again here, for this composition, as long as this is any real number, right away we can jump into our result, negative 1. It's only when we flip this around, let's say arc tangent of, let's say, 7 pi, and let's do, how about 5 pi over 4. Okay. All right. Now again, this does not equal to 5 pi over 4, right? The reason being is that this angle has to be between pi over 2 and negative pi over 2, excuse me. Okay, so what we can take is that this 5 pi over 4, right, is here, so that would give me a positive 1, right? So essentially what we're after is arc tangent of 1, right? But the angle that gives me 1 between quadrant 1 and quadrant 4, and that value is, in fact, pi over 4, right? The ratio of those is 1. Okay? All right. Now what about when we mix these up? Let's say that the compositions, how about we have sine of arctangent of negative 3 over 4. Okay. Okay. So here, again, right, whenever you see something like this, I want you to look at the inner function and treat this as an angle, right? Arctangent of negative 3/4 is equal to some angle t, right? And this is true if and only if tangent of t is equal to negative 3 over 4, right? And again, right, angle restriction, t must fall between pi over 2 and negative pi over 2. So t is, since it's negative, somewhere right here. All right. And that means that the opposite is negative 3. The adjacent is a positive 4. And some Pythagorean, we see that this is 5. So now we have, okay, that means that arctangent, excuse me, let's go up here. Doing some substitution, sine arctangent of negative 3/4 I define to be t, sine of t, and now we can get t, sine of t from our triangle here, and that is, what do we have here, negative 3 over 5, all right, opposite over hypotenuse. Okay, so that's how you work with compositions of these mixed values here. All right, now to wrap up this video, we still haven't talked about the cosecant or the secant, so we'll do that now. So we're going to be working with the cosecant and the secant. All right. Now, unfortunately, the arc cosecant does not equal to 1 over the arc sine of x. Okay, very common mistake, right? They are related in a way, but it isn't. This is not their relation. Okay. All right. So in fact, the way they're related, right? Again, let's go back. Arc cosecant of x, that's equal to some angle t. Right? And the way we define inverses is, this is true again if and only if cosecant of t is equal to x. All right. Now we have reciprocal identities for the cosecant, right? Not the arc cosecant, but the cosecant. So here, this we have 1 over sine of t is equal to x, and taking the reciprocal of both sides, since we do have one fraction equal to another, we have sine of t equals to 1 over x. Well, sine of t is equal to 1 over x if and only if, so here, if and only if arc sine of 1 over x is equal to t, right? That's the relation, right? That's how the sine and the arc sine are defined. Well, what else is equal to t? Arc cosecant of t. So what we have is this property. We have that the arc cosecant of x is equal to the arc sine of 1 over x. So there is a reciprocal involved. It's just of the argument, not of the whole function itself. All right. And for this case, the domain of this function is for the absolute value of x has to be greater than or equal to 1. All right, not less than, greater than, right? Remember the graph of the cosecant, right? Those are kind of the one that breaks up and goes to from 1 to infinity and from -1 to -infinity. Hence the flip of the inequality. The range is also a bit different. Notice for the sine, it's between negative pi over 2 and pi over 2. But when we take a reciprocal, 0 is in there, so we cannot have 0. The range is going to be from negative pi over 2 to 0, union with 0 pi over 2. Okay. And in a similar fashion, all right, I won't go through the whole derivation process. We can define the arc secant, excuse me. Okay, so we can define the arc secant of x to be equal to the arc sine of 1 over x. And in this case, our domain for the values of x, they have to be, the absolute value of them has to be greater than or equal to 1. Again, this is equivalent to saying x is bigger than or equal to 1, or x is less than or equal to negative 1. And then the range goes between 0 and pi over 2, union with pi over 2 and pi. Okay. All right. Because at pi over 2, again, the sign is all right. Excuse me here. This was arc cosine of 1 over x. All right. Okay, and again here excluding pi over 2, because that's where the cosine gives a value of 0. All right, so let's look at some examples here. Let's say if we're dealing with evaluating arc secant of 2, right away you can say, all right, well, this is the same as arc secant of 1/2. Excuse me, no, early this morning. Arc cosine of 1 over 2. Okay, and again, cosine between 0 and pi, positive, first quadrant, 1/2 corresponds to an angle of pi over 3. All right, and then a composition, if we have, let's say, arc secant of 5 pi over 4. Again, be careful here with the composition, as this is not always equal to 5 pi over 4, and we can see it won't be because the angle should be between 0 and pi. So the way you think of this is, again, arc secant of 5 pi over 4, that is in quadrant, excuse me, that is in quadrant 3, so we get a negative root 2. Arc secant of negative root 2. Use the reciprocal identity, but again, not of the whole thing, of, oh my goodness, arc cosine of negative root 2 over 2. All right, and then the arc cosine, an angle between 0 and pi. Cosine is negative in quadrant 2, and then negative root 2 over 2 corresponds to a 3 pi over 4. Okay, and that's how you work with the cosecant and the secant.